we turn this into 0042 in order for you to have the same number of digits as the highest 5-digit number. So yeah, so the number of digits and the column will be uniform. So yeah. And then we have to obviously fix typos, right? Like for example, we want to write COVID, right? COVID, and let's assume it's going to be capitalized, right? So co, and then ideally it should be like this, right? COVID. But let's say you turn so you must type, right? The I turns into U, and then COVID, right? Or for example, co, and then like yeah, uppercase I, and then COVID, right? So it has a different meaning, right? And then you may want to fix the typo like this into just COVID. Yeah. So yeah, that's an example. Those are just some examples of um, syntax errors, and we have to try to fix it. Okay. And last but not least, we have feature scaling, right? So um, before we start talking about the different methods in feature scaling, we have to first talk about why it matters. Because simply put, you know, it improves the performance of some machine learning algorithms, but some others don't. Like, for example, uh, it improves the performance of gradient descent based algorithms and distance based algorithms, but they don't actually improve the performance of tree based algorithms, you know. So let's just put it out there. Improves gradient descent and um, distance based algorithms, but um, tree based algorithms are uh, are unaffected, are unaffected, yeah, are invariant to it. Okay, and then essentially we have two methods, right, to do feature scaling. First one would be standardization, and the second one would be normalization. So what makes it so different, right? So normalization typically rescales the value into a range from 0 to 1, right? But standardization typically means rescaling the data to have a mean of 0. So the mean has to be in the middle, and the standard deviation will be uh, a unit of 1, right? So we calculate the standard deviation, and um, that it becomes like the 1 in the scale, right? And then we try to fit like every single data into like that particular scale, right? From the mean and the standard deviation, you know. And you know, from feature scaling as well, we can actually do um, further analysis on, like, for example, we try to find the outliers as well, like for example, okay, maybe later, finding outliers, like for example in standardization, right? Typically you would want you you consider a data to be an outlier if it has twice, 3 times the standard deviation. Yeah. uh, so yeah, how it works is essentially very simple. So um, let's just say we have like 10 data, right? And so the formula is very simple. How it works, let's just say normalization, standardization, uh, let's add some uh, equation. Okay, so x uh, suppose and then we would want this x minus x minimum value over x max value negative subtracted by minimum value. So this is the formula for normalization. I'll just make that a bit bigger. How do I make it bigger? No. Okay, let's just make it bigger. Yeah. So that's essentially the formula. Okay. And okay. So essentially we just need to put every single data in this one x here, and then we try to find the minimum value, like the lowest value in the data, and then the highest value in the data, and map each and every single data in the column to this to normalize it, right? So, and then for this one, for standardization, is very simple. Let's replace. No. Let's replace this with, do I have the symbol? Let's use alpha, and this one is oh no, let's not use alpha, let's use wait, where is it? Okay, let's use this one, right? Okay. And then let's use omega for this one. Or this one. Okay. Right. Where this is that is the mean, represents the mean, and represents the standard deviation. Okay. Okay. All right. Cool. And then finding outliers, right? So essentially, when we represent it, right, and we can simply just like apply a filter. Like for example, if the value of a data is bigger than the the standard deviation, right? Or twice the amount of 3 times the amount of standard deviation, then yeah, we can use, okay, like for example, if the app in standardization, if the absolute value, I suppose we can use absolute value of the row slash data is greater than, wait, you know what, let me check if it's like 2 or 3, but this depends, I suppose. Outlier standard deviation, because I just came up, yeah, sometimes it's like 2, sometimes I heard it's 3. According to Oracle, it says here that it's a certain number of standard deviations away from, I guess you can put 2. I suppose you can put 3 as well. 2 times, 3 times the standard deviation is greater than a certain number of S be away from the mean, it will be considered an outlier. There we go. And just a bit of a reminder, I suppose. So despite you finding the outlier itself, it may mean two things. Outliers may mean it's, a very it might not it's a mistake in the data. Like for example, you have like in physics, for example, you have parallax error, for example, and it causes the data to be very big, right? Or um, for example, yeah, it's just like a mistype or something, and in that case, you can actually ignore that. You can actually remove it, right? But sometimes the outlier itself may provide, because it being an outlier, right? It being an exception, it may provide like um, a really valuable data, in certain situations, right? That may not be obvious and the standard setting that you have, so of course we have to have the domain knowledge in order to decide whether or not the outlier may provide like an important information and whether or not it should be included in the machine learning algorithms as well. Okay, so I suppose that's it for data cleaning, and I'll see you in the next video.